Hi friends, welcome to Math and Focus Singapore Math Student Edition, Course 2A. 1.2, Writing rational numbers as decimals. It has three sections as you can see: terminating decimals, long division, repeating decimals, long division, compare rational numbers. Okay, very simple, easy chapter to do. There's only one thing that you need to know and you're sorted with the chapter. So these two things, as you can see, it's a long division, long division. Okay, the only difference is terminating and repeating. It's a pretty simple, straightforward chapter. Only thing you need to know is a division. So let's first understand terminating decimals, long division. Let's understand this with the help of an example. Supposing you had a fraction 1 over 4. Right? So how do you say this? 1 over 4 or 1 divided by 4, right? So you need to have decimals. So how do you do that? It's 1 divided by 4. You know this 4 in the denominator is your divisor, right? Okay. Now 1 is smaller than 4. You can't divide directly. So you put 0 and a 0 here with a decimal point, right? So now 10. You know your 4 times table, right? So 4 2s are 8. So that gives us the remainder 2. 10 minus 8, right? Again, we put 0 here, and we know 4 times 5 gives us 20 exactly. So this gives us 0, and the process is over, right? So this is your remainder, basically, the last part, and your remainder here is 0. It ended. It terminated. Does that click something? Yes. So it is terminating decimals. So it ends, okay? So that's what the first part is about. Let's move to the second part. As I said before, it is the same thing that we are talking about. Let's go with an example. So this is 1 divided by 3. You know 1 is smaller than 3, so what do? Yes, put 0 here, and a decimal point. 3 times 3 gives us 9, right? Remainder is 1. Again a 0, again a 3, again a 9, and again 1, again 0, again 3, again 9, again 1. So this again is happening 1, 1, 1, 1. And this 3, 3, 3 keeps repeating, right? So yes, this is a repeating decimal. So no matter how many times you do, this is how it's going to work. So the answer is actually 0.333333. How do you write it? 0.3, and you put a bar on the decimal that gets repeated. So your 3 is repeated, so you put a bar on 3. It's that simple. So do you see the process in both the cases same? The only difference is here it ended, here it's not ending, it's going on, repeating, right? So let's take one more example. Let's say we have a number 13 over 12, right? So 13 is inside here and 12 comes here, our divisor. 1 times 12 is 12, remainder is 1. 1 smaller than 12, so we put 0 and we put a decimal. Now we don't need to put a 0 before decimal as we did here because we have some number there already, right? So we put a decimal for this 0 that we have, but still 10 is smaller than 12. What do? One more 0, right? And this time you have to put 0 here because with 10 you could not divide it, right? So you put 0 there. So 8 times 12 is 96. You need to know your times tables very well, and I'm sure you do it, right? That's simple, straightforward. Keep singing them, keep repeating them, hear them all day, and you're done. Okay, so each day try and do 1 times table. Like today you do 2, tomorrow do 3, next day do 4. Keep repeating. Just keep listening to it again and again. Keep singing with it, and I'm sure you will learn it. Okay. So here 100 minus 96 is 4. We put 0. 12 times 3 is 36. 4. Do you see something? Yep. This 4 is repeating. You put 0, 3, 36, 4, right? So it's 1.08333333. So how are you going to write it? Yes, tell me. 1.083. You're not going to write 33333, right? But where will you put the bar? In the entire number? Nope. We'll put bar only on 3 because that's the only digit that's repeating, right? 0 and 8 did not repeat, so we don't put a bar on it. We put bar only on the digit that repeats, okay? Let me give one more example. Say, for example, you had 8.06393939 on and on. So how will you write this? You will write this as 8.0639, and the bar will be on both 3 and 9 because those are the two digits that are repeating, right? So it's simple, quite straightforward, easy to understand. I'm sure you got it. The only thing you need to know is your divisions. Okay, now let's go to this next part. Compare rational numbers. So the first and the foremost thing you need to do is convert them into decimals. And then this is the process, okay? And then you compare them. So let's take an example. 1 over 4 and 1 over 3. We take from here because we have already done the division, okay? So we know 1 over 4 is 0.25 and 1 over 3 is 0.3 with a bar here, right? So now we compare. We know 0.25. Remember, we never say 0.25, okay? After decimals, we always speak them or refer them with the digits. So 0.25. Here it's like 8.0639. It's that way. So it's never 0.25. It's 0.25. So we know this 0.25, like first digit is 3, here is 2, and here is 3. So this is, of course, a smaller number, right? If we had one of them as negative and the other as a positive, see, for example, minus 0.3 and plus 0.25, then what happens? You know that negative numbers are always smaller than the positive numbers, right? So positive numbers are always greater than the smaller negative numbers. Let's take another situation, 0.25 and 0.3, but this time it's with minus signs. So when we didn't have minus sign, it was this first case, right? But now it's with minus sign, and when numbers are with minus sign, both the numbers, remember this rule reverses, okay? So a big number that looks bigger, that is bigger in on a positive side, is actually smaller here in the negative side. So 0.25 is actually larger than 0.3 here. Minus 0.25 is larger, greater than minus 0.3. Okay, let me explain this, or let us understand this with the help of a bar line that we are so used to referring, right? So here is this bar line that we have. Here is our 0, and we know this side we have positive numbers and this side we have negative numbers, right? So now, as we go from negative to positives, as we go from left to right, the numbers keep increasing, okay? And as we go from positive to negative, from right to left, the number keeps decreasing. It's that simple, okay? Say, for example, 1 and 4. We're going from left to right, right? So this is smaller, this is increasing. So, for example, minus 1. But from minus 1 to 1, it's increasing, right? But if we go this way, 1 to minus 1, it is decreasing. Minus 4, it's decreasing, right? So this is a simple thing that you need to know, and I'm sure you know it, and it's quite simple, straightforward. So a quick summary of what we did so far. We have 3 sections here: terminating decimals with long division, repeating decimals with long division, and compare rational numbers. Okay, so this too has the same method. All of them actually has the same method of long division, right? Here it terminates, it ends. Here it doesn't, it goes on repeating, as you saw. And here it's basically converting into decimals first as we did here, and then simply compare them and decide which is a larger and which is a smaller number. So this is a pretty simple, straightforward chapter. I'm sure you all understood it really well. There's nothing much difficult here. And if you still have any doubts, any questions, any queries, feel free to put them in the comment section and I'll try my best to answer them. I'm sure you will look forward to other videos which explains other subchapters and also the independent exercises that you are supposed to solve from the book. Okay, so thank you very much. I'm sure these videos are helping you. Have fun, study well, enjoy your studies. Okay, goodbye, bye bye.